Hey everybody, this is Larry. This is day four of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Hope everyone's having a great week so far. First day back from Labor Day. I mean, I don't know, I don't labor that much, but hopefully it's treating y'all all right. Though I guess I do labor because I ran 10 miles today, 11 miles today, and and yeah, it is called strength running day. So I basically ran 10 seconds faster than my marathon pace. And I don't know, I'm just so tired after that. I took a nap. But now I'm refreshed and hoping to solve this problem quickly so I could get dinner. But yeah, I think one thing I would say is that if you haven't watched my video from yesterday, even if you have solved the problem, do check it out. I give a chat about kind of focusing on what's important when it comes to learning and problem solving. And I know that we're getting a lot of new people, maybe new semester, new people, hopefully. Check that out. Let me know in the comments, either here or there, if these kind of talks are what you want. Maybe I'll spin it out its own video, but that's fine. But yeah, today's problem, we have 874, Walking Robot Simulation. A robot in infinite XY plane starts at point 00, facing north. The robot can receive a sequence of these three possible type of commands: turn left, turn right, and then move forward K units. Some of the grid squares are obstacles. How do I say it like that? The obstacle is at grid point obstacle I xi y sub I. If the robot wants an obstacle, then it will instead stay in a position and move on the next command. Okay. Return the maximum origin distance that the robot ever gets from its origin squared. Alright. The reason why it's squared is actually kind of nice is because the distance of origin distance is x squared plus y squared, the square root of that, right? Now you don't have to do square root, so yay. But alright. Note. Oh yeah, I was gonna say this doesn't matter usually because of symmetry reasons. But because of obstacles, I guess it does, right? So okay, so I think this is a pure, for the most part, I mean, an implementation problem, right? Or a simulation problem. A simulation problem that is mostly an implementation problem, right? And what I mean by that is that they pretty much have given you everything you need to know. Maybe they could have defined what an Euclidean distance is for our friends who might not, just haven't done it before. But otherwise, I think this is pretty straightforward in terms of what they want, or at least, yeah. So okay, so the implementation is about setting up how to write these things as easy as possible, right? And definitely, if you haven't done it yet, I'll let you pause here and just go ahead. But let me do my little dance. I'm weird. But anyway, yeah. Now that you've unpaused, or maybe just never paused, I think one thing that I would say about these things is that it kind of, it's just about practice and experience, right? And kind of just learning from other people's code. I think if you write a lot, the two things about writing a lot of code for a problem like this is that one, it just takes more time, right? I think it's obvious, and it looks kind of like wonky. There's a lot of special cases. There are so many if statements, right? It just takes more time, right? Which is, it is what it is, right? But also, it's not that bad, honestly, because who cares if you finish this in 20 minutes versus 10 minutes on some, homework assignment, right? I mean, during an interview or maybe a contest, that may be an issue. Yeah, and this is part two, is that the thing is that the more code you write, the more places you can make a mistake on a silly way. I mean, look, we can make, or if you watch enough of my videos, you know that I can make a mistake in any lines of code. I don't need that much code to make mistakes. But that said, the more you write, it's not even that you make mistakes in logic or anything like that per se. It's just there's just so many ways to make typos. And in Python, at least for me, that's my people ask me about Python, and one thing that I always a little bit annoyed about, or like one of my pet peeves, I suppose, is that it's not really a pet peeve, or it is a pet peeve, but it's nothing actionable because this is Python, right? Is that without type safety, there's just and warnings about variable shadowing, which is a big one for me, at least on in terms of contest and competitive. It's just like I make a lot of silly mistakes, just reusing the same variable name or something like that, right? Anyway, that's kind of the how I want to think about this problem, is that there's an implementation problem. So you should definitely focus. Well, I mean, if you haven't done it before, focus on it first, and then maybe come back a little bit later on the video, but also to your code to see how you can make the code tighter, right? Yeah, that's basically what I want to say. Okay, so this is the way that I'll do it. I don't know if it is the cleanest way or canonical way, keeping in mind that I am still recording these things live. Everything is off my head, and my head is not really that good some days. So I'm gonna make mistakes, etc., right? So don't take it as like the perfect ideal code, but it is probably something that I practiced for a while, right? And if you want the ideal perfect code, just watch another YouTube video. There's so many of them with people pretending that they're perfect, right? So yeah. Anyway, all right. So the first thing I always set up is just like direction that we're going in, right? And usually, or not usually, I don't know about usually, but very often it doesn't really matter how you set this up, right? As long as you get up, down, left, right in some order, because all you're doing is enumerating all 4 possibilities, sometimes 8 possibilities if you do that the diagonals, right? I feel like I'm dancing here. But here we do want to make a little bit of an effort to make sure that we're doing the right thing. And here we are starting north, so let's make the first thing north, right? So north we have, the way that I always set this up is that we have dx dy, and dx in this case, and they tell you north is +1 in the y direction. So let's do that. So 0 plus 1, right? And then here, and it doesn't, and as long as you're correct about it, doesn't really matter, right? The next one we can turn right, but we could, for so much reason, it doesn't, like there's no strong preference as long as you're consistent and clear about it. But for me, I like to turn right, so then going north, and then now I'm going east, right? Hopefully, anyway, because some days I forget which one is east and which one is west, right? So this is north. Let's also add a minor comment, and then of course the other one's going to be south, which is more straightforward. And then now you only have really one left, so yeah, oops. So yeah, and the reason why we want to do it this way is because then now we can say our current direction is equal to 0, because that means that our current direction is north. And to turn left, well, let's just say we turn right first. To turn right, going from north to going east, we can just increment by 1, right? And going to the left, we can decrement by 1. So this is why we set it up this way, right? And also, if you it just allows us to kind of handle this a little bit better. Of course, you have to mod it by 4, or with an if statement or something like that. If it goes out of bounds, then you just wrap around, right? Nothing too tricky, but just things to think about, right? Just putting here for us, right? Yeah. Otherwise, then now we just have to parse the commands. We want to say, okay, farthest is equal to 0. That's just the answer, or the variable that we're setting for the answer. And then for command, in commands, then we can parse it. Oh, apparently it's just a number, right? So okay, so if command is equal to -1, then that means that we turn left, right? So as we already have this, so yeah, so that's already done. I'm gonna yeah. And then I mean, you could do mod, and I usually do mod, honestly, but you can also just do something like this, right? Yeah, just go so that it wraps around, right? Else if command. Oh, I think one thing that I've been trying to get a little better at is Python switch statements. Because I think it's in like the new Python. I don't know when it. Let me know in the comments if you know when switch came out, because I don't know, I've still been, it's not something ingrained into my brain yet, how to use a switch statement. So I am trying to be a little bit like more deliberate about it, especially on the daily videos where it's practice for me as well, right? So yeah, so then match command, so we can have we have a case of -1, right? And then we have, I think this is right, right? And I think one thing that I would say is that you know, you can. This is a good time to kind of be like, oh, okay, well, I see some common pieces. You can factor that out. I didn't do that here because I just want to be a little bit more explicit today. But definitely take those opportunities, right? And then later is how do I know that I can do this, but I also feel like there's a way so that I'm still learning switch statements, so my apologies. But I think there's a thing to like also plug it into a variable. But I feel like I've read something like sorry, hang on a second. I think it's something like for x, if x is something like that, you could say. I mean, I know that this has to be true, but I think this does something, right? Let me just test something real quick. I guess this will be for this anyway, so we can just plug it in. I think this works. Yeah, because then now it prints out the 4 and the 3. So yeah, I'm just trying to also get used to the syntax myself. So yeah, so today we're all learning. Hopefully at home you're learning, and today I'm learning about this. I mean, we don't need it for this particular thing, but you can actually plug it into a variable. So then you can assert x is greater than 0, just as a defensive programming thing, and then just move forward k units, right? So then now we have dx dy equal to directions of current direction. And hopefully I didn't make any mistakes, because that is very awkward. Oh, we did make a mistake with not setting up, But yeah, hopefully I didn't make too many silly mistakes, because, yeah, actually usually I like to write it this way. But, yeah. Wait, don't we have obstacles? Right. Oh yeah, I forgot to handle the obstacles. I think we were just writing this thing and then we forgot. And by we, because I don't know. By we I mean me. But yeah. Okay. So yeah, this is the one with the obstacles, because there is a version without obstacles. But yeah, then in this case, I guess we can't do it quite this way, because we have to. Well, there are two ways you can think about it. Right. You could walk one step at a time, see if we hit an obstacle, or the other thing is that you could like do a line point intersection thing. With like binary search and stuff like this if you want. But for this particular problem, k is going to be less than or from 1 to 9, right? So we can do it one step at a time is my point. So yeah, so actually let's also call this k, because they call it k, right? This is wrong anyway, or it's not sufficient anyway, because this should have been like k. So I'm a little bit sloppy here. But then, yeah, as I was writing it, I mean, I wasn't done. I was just like, okay. As I was writing it, I was like, oh yeah. So you want something like this, but the thing is that now we're like, oh, I guess there is a minor algo thing about obstacles and looking it up very quickly, right? So the thing about this is that the lookup is going to be slow because there are 10 to the 4 elements. So if you do a for loop every time, it's going to be too slow. So we want to put everything into a set. So then maybe we have like an obstacles lookup is equal to a set. Actually, maybe we'll put it after directions. Right. And then now, yeah, for xy in obstacles, we can say I say set, but I guess that's a. What is the thing for set? I'm confused, but okay. Yeah, we can add a tuple xy, and that's all you need. And then now here we want to check before we move it. So then here maybe oops. I always do same notations, nx and y for new x, new y, or next x and next y. You could use it. I mean, I don't know. As long as you're constant about it, so you don't make silly mistakes, it's probably fine. Right. So then we want to make that. Check if it's an obstacle. If nx and y not an obstacle, then that means that we can move forward. So then here we have xy is equal to nx and y. If it is, then we just kind of break, right? Because I mean, this only does up to 10 loops, so it's not a big deal. But otherwise, you want to break anyway. And then here at the very end, after we did all the moving, we want to update, yeah. And this is just going to be the current, from the origin, it's just going to be this thing. If I could type it with proper spacing. And yeah, and that's pretty much it, really. Ooh. Oh, this would be pretty much it if I was correct. Did I miss an obstacle? Move, turn right. -1 is turn left. Oh, what the? Oh, I mean, yeah, it's just a very silly, easy mistake. But why did I think I just confused myself. But also, like, yeah, I don't know. I guess I just confused myself because I was saying, because I think when I was looking at this, and maybe you caught it at home because I didn't catch it obviously, otherwise I've done it. I was like, oh, left, turn right. Yeah, but that's what I was saying, right? Very easy to make silly mistakes the more code you have, and it's still wrong apparently. Apparently. Turn -2 is turn left. I honestly, I'm not gonna lie. This is not great. I mean, yeah, this mistake was pretty bad. I mean, because I think what I was doing was that I was like, oh, I want to do the turn right first, and then I forgot to match this the correct command. And also, I was doing the thing with the switch statement, which, you know, doing two things at the same time, I just missed out. That said, that should be fixed. Well, this is actually what's going to give us a problem anyway, because that's also another typo. Should be obstacles lookup. Huh? But why is that? Like, what's the difference? I mean, that's a very weird thing, actually. Like when you see code that is not doing your expected thing, definitely check it out for learning reasons. I mean, I know why this works because that's my intention. This should work even though it may be too slow, and I'm not understanding why that is. Right? Also, this is double negative, so it's kind of a little bit bad. If you ask me on a code review, I'll probably clean it up. I mean, did I do anything with obstacles by accident afterwards? Huh. I am curious. I mean, it looks like they all... Oh, except for here. But why? Like, I actually expected... Like, I would not expect them to be different. Other than running time. Because in should... I mean, I guess the only thing that's different is that obstacles, as I see it, is an array thing. Versus, you know, like maybe if I did this would work. But that's really... I didn't know that it does comparison for that reason. That's kind of really... a little bit surprising just because everything in Python is magic. That, like, there are a lot of magical tuples to arrays and stuff like this, which apparently does not apply here, which is actually surprising. I mean, it saved me a wrong answer or time limit exceeded, but because what happens if we have the array version is that it actually loops the entire thing, which, you know, it's gonna, if you do it for each command, it's gonna be way too slow for number of steps. But the answer is guaranteed. Okay, I mean, that doesn't matter. I'm actually a little bit surprised. But okay. Well, anyway, yeah. This is basically all I have with this one. Let me know what you think. Thanks for watching. I'm gonna get dinner right now. And if you're curious, I am gonna get some Indian food. Gonna get some saag paneer and what you might call it, lamb vindaloo with white rice. Not Indian, not white rice. Pasami. I'm very excited. That's all I have for today. Thanks for watching. Yeah, everything in terms of complexity, this is linear. This is why I didn't go over complexity that much. It's simulation, and it is linear time, linear space, right? Technically, you could say it also depends on this k factor, because k is a constant factor. It only goes up to 9, so we don't have to worry about it that much. But you know, if k is like a million, then you definitely have to, you know, even though it is still linear, that constant factor is high enough that you might have to do some other funky things about it. But yeah, that's all I have for this one. For this part, it didn't matter. Stay good. Stay. Oh man, maybe I need this. I need the dinner. Stay good. Stay healthy. Do good mental health. I'll see y'all later and take care. Bye bye.